In number 2, letter A, it doesn't say whether you should do the problem with guess and check or a system, so you'll have to decide for yourself which way you want to do it. I'm going to again do this problem 2 different ways. I'm going to show it with guess and check first in this video, and then in the next video I'm going to show it with the algebra or the system. I do expect you to do one way or the other, but I don't care which. So if you want to tune into this video only and skip the next one, that would be fine, because I do still want to show both ways, and then I'll leave it up to you to decide which way is best for you. Either way, I am going to show both. This video will show guess and check. The next video will show the system of equations. So you can decide which way you prefer, but you don't have to do it both ways. If you wanted to use the guess and check method for this problem, start out with what you know. They gave us a table where the first term is 8 and the third term is 0.5. So we need a multiplier that takes us from 8 to something, and then the same multiplier takes us to 0.5. Now, this is where guessing can certainly be strategic, so you don't just have to try a bunch of random numbers. I need to start guessing how to get from an 8 to a 0.5. Well, 0.5 is much smaller than 8. So that's making me think I'm going to have to guess decimals or fractions. Because if I multiply by bigger numbers, like 2 or 3 or 4, the numbers are going to get bigger. Like 8 times 2 is 16. 16 times 2 is 32. That's getting way too big. And if I go really big, like 8 times 10 and times 10, that's way, way, way too big. The only way to make something smaller is to multiply by fractions. Now, if the idea of multiplying by a fraction is just too confusing to you, perhaps thinking about dividing will help. Let's maybe think about dividing. Now, I'm going to end up with a number like 0.5, which isn't the friendliest number, but let's think of dividing things that work nicely with 8, and let's see if we can find something that works. For example, 8 is divisible by 2. Let's try dividing by 2. 8 divided by 2 would be 4. 4 divided by 2 would be 2. That's not going to work, because dividing by 2 and dividing by 2 isn't going to be enough divisions to get me down to a 0.5. So dividing by 2 won't work, but I like where we're going with this, so let's try another possibility. Let's try other things that divide nicely with 8. 8 isn't divisible by 3, but it is divisible by 4, so let's try dividing by 4. 8 divided by 4 is 2. 2 divided by 4 we'd have to do as a fraction. 2 divided by 4 is 1/2. But hey, 1/2, that's 0.5. 2 divided by 4 is 0.5. We could even use a calculator and confirm that. If I do in a calculator 2 divided by 4, I end up with 0.5 either way. So it looks like dividing by 4 actually is going to work, because 8 divided by 4 is 2. 2 divided by 4 is 0.5. So it looks like the pattern makes sense. It looks like we found it. The multiplier is really dividing, and it's dividing by 4. So now we can use a little bit more common sense, and we can continue the pattern. 0.5 divided by 4 must give us the last term. So again, you can use a calculator. 0.5 divided by 4 would be 0.125. So 0.125. I can fill into the table. That looks good. The only thing missing then is the initial value. Something divided by 4 and gave me 8. So we could go backwards. We could figure that if we are dividing by 4, to go backwards you can multiply by 4. 8 times 4 is 32. Or you could figure 32 divided by 4 is 8. And then the pattern just continues and continues and it continues, and it does the same thing all along. Divide by 4, divide by 4, divide by 4, divide by 4. So it definitely looks like we found that the multiplier is dividing by 4. But you notice how that sounds weird? The multiplier is dividing. We've seen this in past examples. When the multiplier is really a dividing problem, we write it as a fraction. 1 over whatever we were dividing by. So since we were dividing by 4, we say that the multiplier is 1/4. That's technically what we're multiplying by. And I know most people wouldn't necessarily need to do it this way, but if you wanted to see it, it's because when you do 32 times something like 1/4, you're actually doing 32 over 1 times 1/4. 32 times 1 is 32, 1 times 4 is 4 on the bottom, and 32 divided by 4 is 8. So that's why mathematically dividing by 4 is the same as multiplying 1/4, but you don't need to know that. You can just say dividing by 4, oh, that's multiplier 1 over 4, and just call it a day. So now we know the multiplier, now we know the initial value. We know the initial value is 32. We are set. We can skip down to part D and write the equation and be good to go. If you wanted to do this with the algebra method, the guess and check didn't work for you, or you just don't feel like guessing, then I'll show you in part C how we can get this with algebra. But again, there's no point if you don't want to. You can certainly figure out how to do this with guess and check only. Skip to part D, write the equation, and then go straight on to the rest of the problems without doing any algebra at all. You make that decision, and you decide if it's worth it to watch the next video or not.